can you raise your hand if you believe that your code that you write is beautiful? Okay. Let's try. Okay. Would you like your work to be beautiful? Yeah, that's right. That sounds like it. So today I'll be talking about payments and the software that is used to collect payments. But I'll also be talking about ownership and beauty, which are the key ingredients to make software effective, regardless of its purpose. You might be wondering why that is important in the talking payments, but to me it is because every time I tell people that I build payment applications, they always go with the same question. Why don't you outsource it to a platform? It's just a few lines of code, right? And to be fair, small businesses should be fine with this. If your company operates at very small scale, you're not technical, outsourcing payments is a very good platform. To a platform is a very good idea. But you see, everyone here is technical enough. Even if you're a solopreneur, this doesn't apply to you. So why is that? Well, first, because every company makes money by giving their customers the opportunity to give it to you. Handing that to a platform who may not have your best interests at heart is a recipe for headaches and problems. And second, because, I mean, at least it's been my experience, maybe it's yours as well, every API that I've integrated with has proven less than satisfactory and less than effective than it looked like in the beginning. And in time, it had to be painfully migrated away, no matter how platform agnostic they claim to be. So every integration has this integration in the horizon. And if that's not enough to convince you, consider this. Do you feel that writing these few lines of code would make you a better engineer? That delegating rather than building is the mark of good craftsmanship? Because I believe it doesn't, and it isn't. Even the great artists of our generation know this. Craftsmanship is not about cleanness, but about getting your hands dirty. Craftsmanship is tied to the feeling that you get when your company is successful and you directly contributed to it. Craftsmanship means writing beautiful code, but also owning it. And that's how work feels like an adventure. My name is Alvaro Duran, and I engineer payment application at Kiwi.com, the leading global travel tech company headquartered in the Czech Republic. Over the last year, we've worked on redesigning the payment application fully in Python. And we now get support to new payment methods with ease that help us give travelers the ability to pay the way they want at scale. And in this talk, I'm going to teach you how. There's a dual nature in payments that Python is well suited to address. But to make that obvious, I want to explain why payments are very deceptive to build and where engineers tend to make the mistakes more often. First of all, regulation. The payment networks impose very specific rules on how money should be handled. To connect directly with Visa, for example, you need to apply for a special membership that is time-consuming and very expensive. So instead, what most companies do is to partner with intermediaries, those called payment facilitators or PayFacs. Those providers I like the process, but the downside is that you're dependent on their APIs to access payments. Regulation means that we're almost always going to integrate with at least one provider. And when I say at least one, it's because as your company scales and starts doing business globally, you're better off partnering with multiple providers. This becomes these benefits buffet, where every payment that goes through your system is routed to the provider that costs the least or gives you the best acceptance rate. If you want to go global, and most internet companies want to, then integrating with multiple providers is a must. But what trips engineers the most is the belief that payment online are card payments. And that's not true. Right? This should be news to you. The payments world has changed, and it's changing really fast. So just to give you an example, can you raise your hand if you've never heard of PayPal? Revolut Pay. Yes, here's the thing. PayPal and Revolut Pay are not card payments. In both cases, you've got a balance that you can top up, and you can use that balance to buy things online. And even if cards are still everywhere, they're very expensive for the businesses that support them. And this is why some stores, you may have seen it, they require a minimum amount to make the purchase in order to use a credit card. Otherwise, you have to use cash. This happens in bars a lot. However, if you go on YouTube and search for payment system design, you'll find the design is heavily card-centric. There's a disconnect between engineers who design payment applications and how people behave nowadays. Globally, everyone's habits when it comes to money has radically changed. And it's all more part because of COVID-19. And there's no way that the ship will stop there. So engineers who choose to focus on cards only nowadays are fools. Flexibility is the key, therefore. Flexibility to change providers under strict regulation, flexibility to adjust implementation so that the payment gets routed to the optimal provider, and flexibility to accommodate every innovation. It's a beautiful challenge. So why is Python well positioned to address this challenge? Because not all flexibilities are equal. Total flexibility is bad because move fast and break things is not something that finance people like a lot. Payment applications must be flexible when it comes to the specific of each payment method, but you don't want them to be too flexible to be unstable. After all, we're talking about money. Wherever you interact with payment application, you want things to remain consistent, invariant, and stable. Because the purpose of a payment application is to hide the nitty-gritty details of what it takes to pay. This fear of instability is behind the adoption that Java enjoyed in finance in the 90s, under the promise of write once, run everywhere. Java belongs in the camp of engineers who reject the move fast and break things by choosing to moving slow and leaving things alone. But that's not the camp we're in. If we tried to build payment applications in Java, we wouldn't be able to adapt to the rapid change that the payment industry is experiencing. Flexibility is not idiomatic in Java, it's too verbose. And if you ask me, it's not beautiful. On the other end, there's Ruby. Lots of companies have used it, and very successfully, in the early stages, because it provides a great deal of flexibility. However, it's been obvious that there's a subset of problems that things like type systems and all the stability features are poised to address more beautifully. Ruby's, though, have more or less rejected this idea, trying to preserve a sense of playfulness at the expense of effectiveness. So Python is right in the middle of these two approaches. It's flexible enough to move at pace, and it's been refined by the widespread adoption. It now supports many desirable features for building stability into your system. Python, and this is something that I think all the programming language communities on the play benefit tremendously from network's effects. As far as open source libraries go, we Pythonistas are used to a level of support that is unheard in other languages. I mean, look around. We Pythonistas are the biggest pool of developers when it comes to language adoption, and it shows. That's why when a provider builds an SDK, they tend to build it first in Python. Python is therefore the yin and yang of flexibility. It helps engineers move fast enough and improving things over time. It's the perfect payments language. It bears repeating, there's a dual nature in payments, what keeps evolving and what remains stable. If we want to design payment applications effectively, we must therefore build them in two layers, a stable layer on top and a flexible layer on the inside. But more importantly, these two layers must remain only in one direction. What I mean by that is that flexible layer knows about how the stable layer is built, but not the other way around. Abstractions should never depend on details. These designs shouldn't only favor this relationship, but it must prevent it from going the other way around. And for that reason, inheritance doesn't work. That's because inheritance allows for a bidirectional relationship. Look at this. I can use the members from the parent class in the child, and I can just do things around. Having children being a parent means that they gain access to everything that belongs to them, polluting the code and making local reasoning impossible. This is a mess, and therefore we must employ composition. So this is the strategy pattern. You can look it up in Wikipedia. The key here is to notice that the parent has a child rather than being a child. The subclass is an attribute and doesn't have access to anything that belongs to the parent, whereas the parent can simply invoke the child and access everything it's got. And if you've done anything with React, you know what I'm talking about. So look at this. I have two contexts built with different strategies. And these the strategies are being applied consistently by the same context class using the same method. The context doesn't change, and that meet happens inside the strategies. Now, how does this manifest in payments? Well, surprisingly, this isn't flexible enough. So when it comes to payment methods, copycats are everywhere. Like, raise your hand if you honestly believe that you know what's the difference between Apple Pay and Google Pay. Oh, really? Okay, good stuff. You have to implement them to find that out. Many parts are just the same, but some things like the structure of the requests and the responses and the endpoints they're being called, that kind of stuff, they're different actually, yeah. But if I want to implement the strategy pattern for Apple Pay and Google Pay, how should I go about this? Should I go the route of having a single strategy for each one of them and giving up on code reuse? Or should I have a company pay strategy of sorts where I pass an argument that I will explode into who knows how many if statements inside that class? I didn't say I want to write beautiful code. This isn't beautiful. So how do we solve this? Well, we relax the boundaries of what a strategy is. Instead of forcing the strategy to be a standalone class, we can replace the idea of strategy with a list of classes that we can call blocks. Like a blockchain. I surely wish the name wasn't taken already. So check this out. The payment flow has an attribute blocks, which is a list, and the method is meant to loop through all the items inside that list, so they can call run in each one of them. Each block can then be a class that implements a run method and does whatever it needs to do, specifically built for the task that it's meant to do. Notice how easily it is read the first half and then the second half, as if turning a page from a novel. Now, the whole payment flow is the context, and each instance is a strategy. Depending on the blocks that you pass onto it, you get a different result. Isn't that beautiful? We can now build a list of blocks for Apple and Google Pay, and each one of them having parts that are common, like the prepaid check, and parts that are unique to each one of them. And we no longer talk about strategy, so that's the downside, but I think the overall effect is way better. The problem, though, is that what is happening inside that payment flow? It cannot change across all paying methods. So how do we define these methods? What is common across all payments? And not that we're not running about options here. This is what you get when you search for payment method ecosystem. It's word salads, it's tiny logos, it's a Cambrian explosion of ways to move money around. Is the task even possible? Can we define payments in terms of technology? Well, my answer is obviously yes. The reason is that we figured out a way to classify payment methods that not only it's simple enough for me to spend the rest of these talking about, but it's also exhaustive. And that means that every payment method that exists, has existed, or will exist, can be placed somewhere in this taxonomy. Curious? Okay, let's go. A payment is a promise made by an authorized party. A payment is a promise made by an authorized party. I chose those words carefully because both the concepts of promises and the concept of authorization are actually computer science concepts. One is related to the sync and async communication, and the other is related to identity management. And that means that we can place all payment methods along two axes, whether the customer needs to perform some action to become an authorized party or not, and whether the payment finalizes synchronously or asynchronously, like promises. Like good engineers, we've taken an impossible task, which is figuring out what's common across all payments, into a tractable problem, figuring out a way to manifest these two dimensions in the code. So let's start with identity management. How do we make sure that both the with and the without customer action flows can be supported? One possible way is to make the pay method private. And that means we design the application so that the pay method can only be called in one of two ways. At initialization, where every payment goes first, the block can give us three kinds of results. Success, in which case the pay method gets called directly, fail, and you just return. And also requires action, which is a special in the sense that it returns like fail, but it's meant to be called again. Because inside the response, there's metadata for the client that is going to show the customer what action to proceed with. And they can do whatever they have to do. And then, if the action is completed, some other action data will be sent to the request to another method, when we call it process actions, which will be either successful and therefore will lead to calling this pay method, or it will fail. This is elegant because sometimes you have no idea whether the provider is going to require some action from the customer. Like, for instance, if you pay with a card in Europe, you're likely to be redirected to your banking app. But outside, it rarely happens. This is actually the perfect segue to talk about async versus sync flow. And you see, sometimes the customer isn't immediately requested to complete an action. More often than not, the provider is the one asking the customer to complete the action with a banking app or something else out of your control. Your payment application will hang because now your user have to go through the app, spend some time there, and return if they ever do. Thankfully, the provider won't leave you hanging. Instead, it does what everyone here, I believe, is expecting. It returns a response with the status pending, and will call a callback URL with enough data so that you can acknowledge that the payment has gone through. And in order to accommodate both flows, you can split the pay into the pay process into pay and process pay methods. You can call pay, which may go immediately after process pay if the flow is synchronous. Or you can wait for the webhook to call the callback URL, which will trigger the process pay method if the flow is synchronous. Now, that's a theory. In practice, the provider will be messing with you, and big time, because these providers have agreed contractually that you will be notified of 99.999% of all the payment request outcomes. And that means that they're designed to bombard you with multiple notifications just to guarantee that. And this is actually good news. No payment gets forgotten. But the bad news is that the payment may go through the sync and the async process at the same time. These, at least once delivery, is prone then to race conditions. And race conditions are the worst thing in payments. When that happens, multiple payments get accounted for, when in reality only one has happened. You lose money on every transaction when a race condition happens. And I mean, this is supposed to earn you money instead, right? So how do we fix this? One way is to place a decision logic right in front of the calling of the blocks. This is a mutual exclusion thing for those definition nerds out there. The payment gets transitioned to process pay started or whatever. And so if one thread invokes the method while there's another one running it, it will get rejected. And this is very elegant because there are other situations in which the decision logic could be helpful, like preventing over refunds, retry payments, etc. And these design can accommodate that and more. And to bring this home one more time, payment applications are designed with flexibility. Python's key feature is the foundation of payment applications. It's what keeps developers in sync with the hectic payment industry, while at the same time maintaining control and stability. Composition and the chain of blocks is the manifestation of that flexibility in the code. Instances become the real-world implementation of the abstracted payment flows. And speaking of payment flows, a design based on a technical definition of payments is how we implemented those abstracted classes, where we are making the pay method private to accommodate customer actions, splitting pay method into two methods for sync and async flows, and wrapping them with a decision logic mechanism to prevent race conditions. And if this has resonated with you, I got a surprise. I've been working on a Django package that ties all together, and it's called Django Acquiring. If you like the talk, you should give it a star on GitHub. I hope I've convinced you that building a payment applications not only is easier than you thought, but it's also very, very exciting. This is how we redesigned payments applications at kiwi.com, and I couldn't be happier about it. Not because it's simple, because honestly it isn't, but because thanks to this, work feels like an adventure. Enjoy the rest of the conference.
Thank you. I have a question actually. How does this scale? So when you get to more and more payments, how do you scale this? Is this like a vertical scaling, horizontal scaling?
So in some sense, this is actually positioned to address the scalability really well. This decision logic mechanism is meant to be used not only because your provider is pestering you with notifications, but also because you can scale it horizontally pretty well. One thing I would warn is against the idea that just because payments is scale by design, that means that you need lots of distribution and scalability and all that stuff. In the end, what happens is that even though the scale is big for payments, it's spread throughout the global world. Not everyone is paying at the same time. Some people are sleeping. And that means that you don't have peaks. You tend to have a much more stable kind of scale, which allows Visa to only have 6 data houses spread throughout the world.
Yeah, so how about the Black Friday and all these?
Yeah, I mean, yeah, in a sense, yes. But still, I don't think, unless you will grow to be really, really, really big, the scale in payments isn't as important as all the paid parts of the whole business code. I haven't had the experience to be it that way.
Yeah, okay. This is maybe related to the question that we actually got here. Execution speed in Python. So when you get to these micro transactions, which you get like really, I don't know, like, I'm not sure about this case, but when you are working with this stock exchange, they are really picky about getting to really lots of transactions done in a tight deadlines. Yeah.
Yeah, so there's a difference between stock exchange, where you are constantly interacting with the provider, and this side. What I would say is that what gets engineers that build payment applications the belief that they have to make the code really, really complex to adopt to that scale that never happens. And you losing out on the ability to read and to understand and to extend it with the new payment methods. Your problem isn't scale in the sense of accommodating more users. Your problem is scale as in being able to still understand the system you're working on.
Yeah, complexity. Yeah. Okay, thanks. How about security? Whatever that means.
So security, I think it's built into the process. No provider is gonna allow you to give payments the ability to accept payments unless you have procedures and ways of doing things the way they want you to do that. So part of the integration with a provider involves providing these measures of security. The devil's in the details, though. There's a level of fraud that you're okay living with as long as the acceptance rates keep going higher or keep maintained at a higher level. You have to be okay with some level of fraud as not so that you don't crush customers with impossibly horrible friction processes that will never lead to pay or lead to conversion in the first place. So you need to be very careful about that in terms of fraud, which I believe that's what security means in this question.
Kind of, probably, yeah. Nobody's going to steal your data center hard drives, yeah. How about Python execution speed? I read that. Maybe I missed, but will your solution handle all card providers?
Yeah, so execution speed, as I said, that's what tricks this kind of stuff. It's not execution speed which matters counterintuitively. I mean, it matters to some level, but not the level that you were expecting. In terms of card providers, I think it does. I think the ability to create new blocks independently of each other means that you can handle things independently of each other. Yeah, in the end, the solution could be made orthogonally in that sense. You don't need to do something specific for both Visa and MasterCard and pester the code with if statements. You can do like two things independently of each other.
Okay.
Yeah, if
there's a
resolution
link.
public, as you can see, the latest question, he figured it out, or they figured it out.
Yeah, and main bottleneck of processing millions of transactions are what database? Yeah, so
on the second way.
So the main bottleneck of processing millions of transactions should be database. But is this the case in your situation?
So as you've seen, this isn't talking about databases. And I got another talk on this topic, but my 2 cents on these is that there's a database for each use case. In our case, something relational has worked, but maybe at some further scale, we need to accommodate a different database engine. And this flexibility also applies to databases, but the way you handle that is a bit different.
We know that Kiwi built their own database for all this complex search.
Yeah.
So obviously, making something quicker in this sequential writing, could be doable. Examples about whether to choose Apple Payment or Payments Apple,
Single responsibility principle. You prefer to avoid it in your case.
Yeah.
I think this is an amazing question. This is the meat of the design. I wish this was voted up a bit more. This is the meat of the talk. What is the difference between doing one or the other? If you do the first, then you're going to have something that is too flexible that you're going to have to handle things very independent. Apple is going to be handled very independently of the rest. And the problem is that, as I said, there are parts of the Apple process that are common to Google or Alipay or Amazon Pay or whatever Pay, because every big company now has a Pay as well. Again, payment industry evolving really fast. So there's parts of that that are very, very common across all of these micro ecosystem. So you're losing on the ability to reuse that code. If you do payments with configuration, then you're going to have lots of if statements happening. If company equals Apple, then do this. If company equals Amazon, then you do that. And neither of those options are okay. I mean, you can live with them, but the experience is that the complexity of the code ends up escalating and becoming untenable. So neither of those solutions are optimal, and both things are kind of right. So that sounds like something in the middle is probably the optimal way, and that's like, again, the meat of the talk.
And there's also a possibility that also, even when you use Apple Pay or whatever, those parts change eventually, yeah? So
Yeah,
you have
exactly.
to accommodate for some...
Exactly, yeah. So one of the things that, so two things that I haven't talked really about is the ability to decommission things that are no longer the case. If you rely on blocks, then those small parts can be plugged out without affecting the rest of the code. And yeah, that gives you that extra flexibility when the time comes, because it will come when you have to decommission certain parts of the payment system, because it changed, because they changed their mind. You can never predict the future.
Thank you very much. So I think that will be it.